Substance P and NAS911 work by attaching or binding to another molecule called a receptor that is on the surface of most cells. There are thousands of specific receptors for thousands of specific chemicals that the body uses to function. But the specific receptor that Substance P and NAS911 bind to is called the NK1 receptor. Substance P also binds to similar receptors called the NK2 and NK3 receptors, but NAS911 was created to bind more specifically to the NK1 receptor, and this is one of the ways in which it acts differently from Substance P. Interestingly, early studies found that NAS911 worked opposite the way Substance P was expected to work in lungs of animals that were exposed to toxic fumes in the air. And we followed up with studies that continue to look for differences in other organs and under specific situations. In this way, we found that the impact of NAS911 included the ability to stimulate the bone marrow to make and release more blood cells, and this stimulation of bone marrow stem cells was associated with experimental animals surviving what would otherwise have been lethal exposure to radiation. This was surprising, but we have shown this multiple times and have found that this protection is at least partially due to this ability of NAS911 to stimulate bone marrow stem cells to generate new white blood cells, which are an important component of the immune system. Radiation exposure damages these bone marrow cells, and irradiated animals then can't make enough white blood cells to fight off normal infections. When irradiated animals get exposed to normal bacteria or viruses, they can't fight off the infection, so they get sicker and die.